Today we will study regarding terminology of coordination compounds. And today we will study what are ligands and what are its types. Ligands and types. First of all, we will study ligand क्या होता है. जो word ligand है, it is derived from a Latin word that's called liger, which means to bind. The word ligand is derived from a Latin word which means Latin word liger, which means to bind. So ligand is a neutral molecule or an ion, whether it is cation or anion, which is directly linked to central metal atom or ion is a ligand. The neutral molecule or an ion, whether it is cation or anion, which is directly linked to the central metal atom or ion, is known as ligand. Ligands जो होते हैं, they are attached or they are bonded to the central metal atom through coordinate bond. They are attached to the central metal atom through coordinate bond, or we call it the dative bond. That means ligand has lone pair of electrons, lone pair or lone pairs of electrons, which it uses for donation. So, for example, if I will take the example of ammonia, this is ammonia. Nitrogen has lone pair of, in case of ammonia, nitrogen has lone pair of electrons on which is non-bonded. So this lone pair is used for donation, so it can act as a ligand. Similarly, water molecule, it has lone pair of electrons, two lone pairs, so it uses its lone pairs for donation to the central metal atom, so water molecule acts as a ligand. Similarly, cyanide ion, it can, nitrogen has lone pair and carbon has also lone pair, so these lone pairs are used for donation or for bonding coordinate. These are used for donation. These electrons are donated to the central metal atom through the coordinate, so they form the coordinate bond, so it's a ligand. Similarly, if we take the chloride ion, so it is electron pairs for donation, so these ligands have lone pair of electrons which it uses for donation to the central metal atom. Now, since ligands जो होते हैं, they donate electrons, they donate electron pairs, electron pair or pairs, so they are electron donors. They are called, we can call them, so they are Lewis bases, because they donate the electron pair to the central metal atom. They are Lewis bases. Similarly, if we take the case of central metal atom, it accepts the electron pair. It accepts the electron pairs. It accepts the electron pair which is donated by the ligand, electron pair or electron pairs. So central metal atom acts as an Lewis acid. So central metal atom acts as a Lewis acid. It can be a Lewis if we call it a Lewis acid. Now, इसका मतलब है, फर्स्ट जो लिगेंड है इसकी एक कैरेक्टरिस्टिक है, लिगेंड मस्ट हैव lone pair of must have lone pair or lone pairs of electrons which are non-bonded, lone pair of electrons, which electrons on it. So these lone pair is used for donation. Number second. Now central metal atom जो है, it should must have vacant orbital of equivalent energy. Vacant orbitals which can accept the electron pair or electron pairs. So this is necessary for the central metal atom, that it must have vacant orbital of equivalent energy which can accept the electron pair or electron pairs donated by the this ligand. Now most of the reactions, if we study most of the reactions जो होते हैं in of metal ions in aqueous solution, जो हम aqueous पानी में जो reactions हम करते हैं of metal ions, they are actually complex ion reactions. That means most of the reactions in the of the metal ions in the aqueous solutions are actually the reactions of complex ions. For example, if we take cobalt triphosphate, it is it exists in water. For example, CO H2O whole 6. So most of the reactions are due to the formation of complex ions, due to the formation of coordination complexes. Similarly, if we take nickel, it exists in water. For example, nickel diphosphate, nickel H2O whole 6 diphosphate. So most of the reactions in the metal ion in the aqueous solutions are the reactions of complex formation, complex compound बन जाते हैं. Similar, for example, if we take aqueous solution of nickel जो हम लेते हैं, nickel diphosphate ion, if we add ammonia to it, so ammonia gets replaced. This water molecules get replaced by the ammonia, so it gives NH3 whole 6 diphosphate, and this this is green color, and this becomes the blue color. So most of the reactions of metal ions in the aqueous solution are due to the because of the complex formation. Now if we see the type ligands, depending upon the number of donor atoms, number of donor atoms कितने हैं, या how many electron pairs are donated, these ligands can be classified as, for example, first it is monodentate ligand, or we call it unidentate. So what is monodentate or unidentate ligand? By the name, mono means one, so that means which has only one donor atom. That means it can donate one electron pair, or it can form coordinate bond. It can form coordinate bond with the central metal atom through one side, through one position. It has only one donor atom, and it can donate one lone pair of electrons, or it can form one coordinate bond to the central metal atom. For example, if we take ammonia, in case of ammonia, there is nitrogen donates the lone pair of electrons, so it's only nitrogen, so it is a unidentate ligand. For example, in water, oxygen donates the lone pair of electrons. Similarly, in case of phosphine, phosphorus donates the lone pair of electrons. Similarly, if we take case of carbon monoxide, we call it carbonyl Oxygen donates the lone pair of electrons. Similarly, and nitric oxide, we call it nitrosyl. Nitrogen donates the lone pair of electrons. Similarly, if we take the hydroxide, oxygen donates the lone pair of electrons. Similarly, if we take the cyanide, carbon or nitrogen can donate the lone pair of electrons. Nitrogen in case of cyanide, carbon donates the lone pair of electrons. And similarly, if we take the oxide, it can oxygen donates the lone pair of electrons. So these are, yeah, if we take the phosphine, triphenyl phosphine, C6H5 whole thrice P, and this phosphorus donates the lone pair of electrons. So these are the some of the examples of the unidentate ligands. Unidentate ligands, which has only one donor site. That means they can donate electron to the central atom through one position. Now, accordingly, there can be another type is bidentate ligand. Bidentate ligand, we call it didentate also. Dentate means kala. That means which can attach, which can form coordinate bond at two positions. Dentate means which can which can coordinate the central metal atom at two positions. That it has two donor atoms. Has two donor atoms. And can coordinate. That means can coordinate or can form a coordinate bond to the central metal atom at two positions through two sites through two sites, or we can form the coordinate bond at two positions. For example, if we take uh, oxalate ion, this is the oxalate ion. So this oxygen can donate the lone pair of electron, and this oxygen can donate the lone pair of electrons. So it is a didentate ligand, or we call it a bidentate ligand. Similarly, if we take ethylene diamine, it donates electron. This nitrogen is used for donating some electron, and this nitrogen is used for donating of electrons. So it is we call it ethylene diamine. It is a didentate ligand. Similarly, glycinate ion, for example, so glycinate ion, this is also a didentate ligand. Here nitrogen is used, and in here oxygen and nitrogen, both these are used, and both these contain lone pair of electrons, and they are used for donation to the central metal atom. So these are bidentate ligands. Now students, in case of glycinate ion, there are two oxygen atoms which are used for donation. That means two donors are of same type. Here is oxygen and oxygen. Similarly, in case of ethylene diamine, nitrogen and nitrogen. So these which have same donor atoms, in case of bidentate ligands, if the two donor atoms are of same, so it is called symmetrical bidentate ligand. That means in case of bidentate ligand, if the donor atoms are of same type, here oxygen and oxygen, they are same type, so it is a symmetrical bidentate ligand. Similarly, in case of ethylene diamine, two donor atoms here, and NH2 group, nitrogen here and nitrogen here, these donate the electron pairs, so ethylene diamine, it is a symmetrical. And in case of glycinate ion, here it is nitrogen, it can donate the electron, and here it is oxygen, it can donate the electron. So two donor atoms are different within the same molecule. Two donor atoms are different, so this is unsymmetrical bidentate ligand. Similarly, there can be a tridentate ligand. Tridentate ligand means which has three donor atoms. That means it can donate electron it can the ligand which can donate electron at 3 positions, electrons at 3 positions, यानी 3 जगहों से इलेक्ट्रॉन डोनेट करता है. That means it can form 3 coordinates bonds. For example, I'll write ethylene diethylene triamine. So here nitrogen, and here nitrogen. There are 3 donor atoms. This is diethylene triamine. Diethylene triamine. It is an tridentate ligand. Similarly, we can write tetradentate ligand, which has 4 donor atoms, which can donate electron at 4 sites. At 4 sites, at 4 positions, it can donate electron. For example, triethylene tetraamine. For example, here this triethylene, this nitrogen is used for donation, this nitrogen is used for donation, and this nitrogen is used for donation, and this is tetradentate ligand. So tetradentate ligand means which has 4 donor atoms, and it uses 4 uh, uh, donor atoms, that 4, it can donate electron at 4 sites. Similarly, there can be pentadentate ligand, there can be hexadentate ligand. For example, hexadentate EDTA, it is hexadentate ligand. Now, students, a polydentate ligand by the ligands which have which have 2 or more than 2 donor atoms, we call them polydentate. That means bidentate, tridentate, tetradentate, hexadentate ligands are called polydentate ligands. Now, polydentate ligands, they have flexdentate character. What is flexdentate character? That is means it is not necessary that all the donor atoms of polydentate ligand are used for donation. That means अगर कोई पॉलीडेंटेट लिगेंड है या ट्राइडेंटेट लिगेंड है, पेंटाडेंटेट या हेक्साडेंटेट, ये जरूरी नहीं कि सभी वो डोनेट करेगा. So that is flexibility है. It can act as flexdentate ligand. For example, if we take EDTA, ethylene diamine tetraestate acid, tetraestate ion जो है, it is an hexadentate, but it can act as a pentadentate, it can act as tetradentate. So that means a polydentate ligand has a flexdentate character. That is means for a polydentate ligand, it is not necessary to use all the donor atoms for donation. It can act as didentate, it can act as pentadentate. If it is hexadentate, it can act as pentadentate. So this is the flexdentate character. Now, another type of ligand, we call it ambidentate. That means the ligand, it has 2 donor sites. ligand के पास donor sites, 2 donor sites हैं, but it uses only one. Sometimes it uses one atom, sometimes it uses another atom for donation. For example, मैं आपको बता रहा हूँ, let this is NO2. Nitrogen can donate and oxygen can donate. When it uses nitrogen for donation to the metal atom, this is called a nitro group. यही nitrogen अगर ऐसे, if it uses oxygen for donation to the central metal, it's called nitrito. Similarly, carbon, this is cyanide ion. If carbon uses its electron for donation, it is cyano. If it's nitrogen, if nitrogen uses its electron, in case of cyanide, if the carbon donates the electron, it is cyano. If nitrogen donates the electron, that is NC, it is isocyano. So we call them, these are called the ambidentated ligands. Similarly, SCN, if sulfur donates the electron, it is thiocyano. If nitrogen uses, it's called isothiocyano. So this is the ambidentate ligand. The ambidentate ligand means the ligands have more than 2 donor atoms, but they use only 1 donor atom. Sometimes they use one, the group becomes endemic, we call it another name. But if you use another oxygen atom, another atom, then it's another group. For example, you have NO2 group, which is called nitro. If it is oxygen, then it is nitrito. Similar in cyanide, if carbon donates, it's cyano. If nitrogen donates, it's isocyano. So such ligands are called ambidentate ligands. This was ligands. Tomorrow we will study the chelating ligands.